So, let us begin. To understand the birth of a cloud, you must first understand the world not as it appears, but as it truly is drenched in an invisible sea. Right now, in the very room where you are resting, the air that touches your skin, that fills your lungs with every gentle breath, is not empty. It is an ocean. An ocean of air? Yes, but within that ocean, another ocean resides a vast, hidden reservoir of water. Think of the great bodies of water you know. The Pacific, stretching out in an endless blue sheet under the sun. A quiet, glassy lake at dawn, mirroring the trees along its shore. A river, winding its way patiently through the land. We see this water. We can touch it, feel its coolness, hear its rhythm as it laps against a shore. But this is only water in its most obvious form. It has another life, a secret, ethereal existence as a vapor, a gas, as much a part of the air as the oxygen you breathe. This is where the story of every cloud begins, not in the sky, but here on Earth, with a single, tiny molecule of water deciding it's time to fly. Imagine you are standing at the edge of that vast, sun-drenched ocean. The sun, a giant, warm heart in the sky, pours its energy down onto the surface. It is not an aggressive heat, but a gentle, persistent calling. This light, this warmth, travels millions of miles. And when it arrives, it gives the water a gift, the gift of energy. A single photon of light might strike a single molecule of water, and in that microscopic, silent transaction, everything changes. The molecule, once content to be part of the collective, part of the liquid whole, is suddenly vibrating with a newfound vigor. It dances, it shivers with a gentle energy, bumping into its neighbors, until it has gathered enough momentum, enough of the sun's warmth to do the impossible. It breaks free. It leaves the liquid world behind and ascends, rising into the air as a single invisible particle of gas. We call this process evaporation, a word that feels too clinical, too sterile for the magic it describes. It is not an industrial process. It is a quiet, constant ascension. It is the Earth's gentle exhalation. It is the ocean breathing out, releasing a tiny piece of itself to the sky. And it is not just one molecule. It is billions upon billions. A constant, silent river flowing upwards from every sun-touched surface of water on the planet. From every wave crest, from every puddle left after a rain shower, from the dew on a spider's web at dawn, this invisible river flows not only from the oceans. Walk with me, in your mind, into a deep, quiet forest. The air here is different. It's cool and damp, rich with the scent of earth and decaying leaves. Here, the great trees stand like silent sentinels. Their roots drink deeply from the soil, drawing water up through their trunks, up through their branches, all the way to their leaves. And on the surface of each leaf, there are thousands of tiny pores, like microscopic mouths. Through these pores, the tree breathes. It releases water vapor into the air in a process called transpiration. It is the forest's own contribution to the sky, its own deep, slow breath. If you could see it, the forest would look like it was steaming, gently, constantly, releasing its life-giving moisture into the great ocean of air. A single large oak tree can release hundreds of gallons of water into the atmosphere on a warm day. A silent, leafy fountain, contributing its part to the clouds that will later shade it. And this invisible water is even closer than that. With every breath you exhale, a tiny, warm plume of moisture leaves your body and joins the air around you. On a cold day, you can see this personal cloud for a fleeting moment, a testament to the water you carry within you. Every living thing that breathes is a small fountain, a contributor to the atmospheric sea. Every cup of hot tea that steams in your hands is releasing its essence to the air. The world is constantly, silently, beautifully letting go of its water. So, the air around you is teeming with this history. The water vapor in the room with you right now might have been born from the sun-warmed surface of the Caribbean Sea. It might be the breath of an ancient Amazonian rainforest. It might be the ghost of a snowflake that melted on a distant mountain peak. The atmosphere is a library of places, a swirling, invisible soup of memories. It is a global commons of water, shared by all of us, by every plant, every animal, every ocean. It is difficult to comprehend the scale of this invisible ocean. At any given moment, the atmosphere holds more water than all of the planet's rivers combined. It is a staggering amount, a weight almost too heavy to imagine, yet it floats. It is held aloft, molecule by molecule, dispersed and transparent, waiting. It is pure potential. It is the promise of rain, the blueprint for a thunderstorm, the ink for a painted sunset. Feel the air on your skin. If it feels humid, damp, you are feeling the density of that invisible water. You are feeling the presence of a nearby ocean or a recent rain. If it feels dry, crisp, you are feeling the relative absence of it, a sign that the air has traveled over vast, arid lands, but it is never truly absent. It is always there, in some quantity, holding the planet in a delicate, moisturizing embrace. This blanket of moisture is essential for life. It helps to regulate the Earth's temperature, trapping some of the sun's warmth like a greenhouse, preventing the nights from becoming lethally cold. It is a global thermostat, operated by the quiet physics of water. This first stage in a cloud's life is one of invisibility, of quiet gathering. It is the slow, patient accumulation of raw material. Before there can be a form, there must be substance. Before there can be a shape, there must be a gathering of spirit. The atmosphere is doing just that, gathering the spirit of the world's water. It is a slow, methodical process, driven by the gentle, constant energy of the sun. There is no rush. The sky is patient. It can hold this moisture for days, for weeks, carrying it on the great wind currents, moving the memory of the Pacific over the Rocky Mountains, carrying the breath of the Gulf of Mexico up into the heart of the continent. Think of it as a great cosmic inhale. The sun warms the earth, and the earth breathes out its water. The atmosphere takes it all in, holding it, mixing it, carrying it. This is the foundation. It's the stillness before the dance. Every dramatic thunderhead, every wispy, high-altitude feather of ice, every flat, gray ceiling of a gloomy day owes its existence to this first, silent step. The transformation of liquid into gas, the liberation of water from the surface. As you lie here, breathing in and out, you are a part of this cycle. You are breathing in this mixture of gases and this invisible water vapor. The air that fills your lungs is a traveler. It has been places. It has seen things. And with every exhale, you add your own small measure of warmth and moisture back into the great atmospheric ocean. You are, in this very moment, a cloud maker. You are a contributor to the great, invisible river in the sky. It is a comforting thought. Is it not that the world is so deeply interconnected? That the water cycle is not something external? Something you watch from a distance? You are in it. You are part of its machinery. The water that sustains you is the same water that will one day become a cloud. There is no separation. So, let your mind drift with this idea. The idea of an unseen world, a second ocean, layered on top of our own. It is a world of pure potential, a vast and patient reservoir. The water molecules are there, energized, free from their liquid bonds, floating and mixing, waiting for the next step in their journey. They have been lifted from the earth by a gentle solar invitation. They have been gathered from forests and rivers and oceans and from the breath of all living things. They are now part of the air itself, silent, invisible, and ready for the great ascent, ready to be called even higher to a place where the air grows thin and cold, and where the next beautiful transformation can finally begin. But for now, they simply are. They are the unseen, the promise, the quiet and ever-present soul of the sky. They are the first, most fundamental, and most magical ingredient in the recipe of a cloud. That invisible ocean of water, which we spoke of, does not remain static. It does not linger forever near the ground. It is a traveler, and its destiny lies upward, having been freed from the Earth's surface. This vapor, this spirit of water, is now held within vast parcels of air, and it begins a slow, inevitable journey, the great ascent. This is the second step in the making of a cloud, the silent, powerful rise into the higher, colder realms of the atmosphere. Imagine, on a warm, sunny day, you're lying in a field of tall grass. You can feel the sun's energy not just on your skin, but radiating back from the earth beneath you. The soil, the rocks, the dark plowed fields, they all absorb the sun's rays and grow warm. As they warm, they, in turn, warm the layer of air that rests directly upon them. Now, this pocket of air, warmed by the land and filled with that invisible moisture we spoke of, becomes different from the air around it. It becomes buoyant, becomes restless, like a hot air balloon, unseen and immense. It wants to rise. This is perhaps the most common way our atmospheric ocean begins its climb. It's called convection, but let's call it the Earth's warm sigh. Throughout the day, as the sun moves across the sky, the planet is constantly sighing, releasing these enormous invisible bubbles of warm, moist air. The process is gentle, almost lazy. The bubble doesn't shoot upwards like a rocket. It simply, gracefully, unsticks itself from the surface. It begins to float, slowly at first, and then with more certainty, climbing through the cooler, denser air that surrounds it. If you were a tiny seed, caught in this rising thermal, your journey would be one of profound peace. You would feel yourself lifted, weightlessly, without any effort. The world below would slowly shrink. The field you started in would become a patch of green. The nearby woods a patch of darker green. The houses would become like tiny pebbles. You would be rising on a silent, invisible elevator, powered by nothing more than the warmth of the ground. Eagles and hawks know this well. They are masters of the ascent, circling within these rising columns of air, letting the Earth's own breath do the work of carrying them higher, saving their own precious energy as they scan the ground for prey. They are riding the very same currents that will eventually build a cloud. As this parcel of air rises, it carries its precious cargo of water vapor with it. It's a delivery service, a transport system for the raw materials of the sky. This is the journey that carries the memory of the ocean, the breath of the forest, up, up, up into the vast blue emptiness. The ascent is a journey of transformation, for as the air rises, the world it travels through begins to change dramatically. The pressure of the air around it lessens, and the bubble of rising air is free to expand, to stretch out. And in this expansion, it cools. It's a fundamental law of the universe, a bit of cosmic magic. When a gas expands, it cools down. It is giving away some of its energy to the act of growing larger. This is the key. The ascent is also a journey into cold. For every 100 meters it rises, the air cools by a predictable amount. It is trading its warmth for altitude. It's a slow, steady chilling, the first hint that another state of being is on the horizon. The water vapor within it, still invisible, still a gas, is being carried into an environment that will soon become hostile to its current form. It is being taken to a place where it will be forced to reveal itself. But the Earth's warm sigh is not the only way the ascent begins. There is another, more majestic, more patient form of lift. Imagine a long, slow-moving river of air, thousands of miles wide, flowing across the landscape. This is the wind. It is another part of the atmosphere's circulatory system. And sometimes this river of air encounters an obstacle. It is not an obstacle it can go around. It is a mountain range. Think of the great mountain ranges of the world, the Rockies, the Andes, the Himalayas. They are like giant, sleeping stone walls in the path of the wind. The air, full of moisture from its long journey over an ocean, cannot stop. It cannot go through. It has only one option to go up and over. We call this orographic lift, but it is better imagined as the world's gentlest persuasion. The mountain does not violently shove the air upwards. Its long, sloping foothills and rising peaks provide a ramp. The air is gently guided, nudged, and encouraged to climb. This is a slow, methodical ascent. An entire ocean of air being lifted for hundreds, even thousands of miles along the face of a mountain range. It is a far grander and more organized climb than the bubbling, chaotic thermals rising from a field. It is the entire system moving as one. As this vast sheet of air is forced to climb, it too begins to expand. It too begins to cool. The higher it climbs the mountain's flank, the colder it gets. It is a pilgrimage into the sky, and the mountain is the temple that forces the ascent. Many of the world's most lush green environments are found on the windward side of mountains for this very reason. The mountains are celestial gatekeepers, forcing the air to give up its moisture, to reveal its hidden water, creating rain and snow that nourishes the forest below. And there is a third way, a way that is not born of warm ground or stony obstacles, but from the meeting of two different worlds. The atmosphere, you see, is not one uniform body. It is made of enormous, continent-sized masses of air, each with its own character, its own history. An air mass that has spent weeks over the frozen Arctic will be intensely cold and dense. An air mass that has drifted over the warm waters of the tropics will be warm, humid, and light. And sometimes these two different worlds meet. Their meeting place is called a front. It is not a violent collision. It is a slow, cosmic dance. The cold air, being dense and heavy, acts like a wedge, sliding underneath the warmer, lighter air, and the warm, moist air, unable to go down, has nowhere to go but up. It glides gracefully, up the gentle slope created by the edge of the cold air mass. This is frontal lift. It is a slow, inexorable rising, not of a single bubble, but of a vast expanse of air, hundreds of miles wide. This is the lift that often brings the long, steady, all-day rains. It's the lift that can create a vast, uniform ceiling of gray that covers the entire sky. It is a slow, patient, and highly organized ascent. You are witnessing the boundary between two worlds, and the result of that meeting is an ascension, a lifting of moisture into the higher, colder altitudes where clouds are born. When you feel a change in the weather, a shift in the wind, a drop in temperature, you are often feeling the arrival of one of these fronts, the edge of a different atmospheric world, beginning its slow dance with the air that is currently around you. So we have these three primary ways of rising: the bubbling sighs of a warm earth, the majestic, patient climb over a mountain, and the graceful gliding dance at the meeting of two different air masses. Each is a different path, but the destination is the same upward. Let your mind float now. Let it become one of those tiny particles of water vapor, caught in the ascent. Feel the lightness, the release from the pull of the ground. Below you, the world is a map of textures and colors. You are inside the breath of the planet itself, a part of its circulation. You are not fighting gravity. You are being carried by a force more powerful and far more gentle. You are riding the currents of the sky. As you rise, that you feel the change. The warmth you started with is slowly seeping away, traded for height. The air around you feels thinner, more spacious. You are entering a different realm, a realm where the rules are about to change. The journey so far has been one of invisibility. You have been a ghost, a secret held within the air, but you are being carried to a place where secrets cannot be kept. You are approaching a threshold, a magical boundary in the sky which is defined not by a line, but by a temperature. It is the dew point, the temperature at which the air can no longer hold all of its hidden water vapor. It is the temperature of revelation. The ascent is the critical bridge between the unseen and the seen. Without this lift, the water vapor would remain forever a part of the air, an invisible ocean with no expression. The clouds would never be born. The rain would never fall. The great water cycle would be broken. The lift is the engine, the active part of the story that connects the earth to the sky. It is the process that makes everything else possible. So, as you rest, feel a sense of lightness in your own body. Imagine the gentle lift, whether it's the bubbling warmth from below, the steady slope of a great mountain, or the slow dance of meeting worlds. The journey is always up. It is a journey away from the familiar and into the realm of pure potential. The cargo is secure. The invisible water is on board, and the destination is getting closer with every passing moment, with every foot of altitude gained. The great ascent is underway, carrying the hopes of the dry earth below, carrying the promise of a shape, a form, a beautiful, visible expression of the water that surrounds us all. The next chapter of the story awaits in the cold. Thin air above, our parcel of air, our invisible bubble of warmth and moisture, has completed its great ascent. It has been lifted by the sigh of the warm earth, or perhaps pushed gently up the long, sloping shoulder of a mountain, or maybe it has glided gracefully over a denser, colder river of air. The journey upward is now complete. But in arriving, it has been profoundly changed. It has traded its warmth for altitude, its pressure for space. It has arrived in the high, thin, and lonely expanse of the upper atmosphere. And it is cold. This coldness is the key. It is the crucible in which the next miracle will be forged. As you float in this high, chilly realm, you can feel a tension in the air, a sense of imminence. The water vapor, our invisible cargo, is feeling it too. The molecules, which dance so energetically in the sun's warmth, are now slow, lethargic. The cold has robbed them of their frantic energy. They move more slowly, bumping into each other with less vigor. They are becoming sticky. They are reaching a point of saturation, a point where the air, in its coldness, simply cannot hold them in their gaseous form any longer. The air is full. It is pregnant with water. This threshold is called the dew point. It is not a place you can see, but a condition. It is the precise moment when temperature and humidity conspire to say, no more. The air is ready to give up its ghost, to release the water it has carried so far. But here, a strange and beautiful problem arises. The water molecules, even though they are cold and slow and ready to cling together, are shy. They need an invitation. They need a reason to gather. In perfectly pristinely clean air, they could remain as a vapor, a supersaturated invisible mist, even below the temperature where they should logically turn to liquid. They need a surface. They need a host. They need an anchor in the vast, empty-feeling space of the sky. And so, we must introduce the unsung hero of our story, an element that is everywhere, yet entirely overlooked. We need to talk about dust. The word dust often feels dirty, unwelcome. It's something we sweep from our floors. But in the sky, these tiny particles are the seeds of creation. They are, in fact, the reason clouds can exist at all. We call them cloud condensation nuclei, a term far too scientific for the poetry of their function. Let's call them the sky's anchors. Where do these anchors come from? They are the Earth, in miniature, sent up into the atmosphere. Imagine a powerful gust of wind sweeping across the Gobi Desert. It lifts the finest, most microscopic grains of sand and silt, carrying them thousands of feet into the air. These tiny specks of Earth can then travel for weeks, carried on the great wind currents, circling the globe. A cloud that forms over Ohio might be seeded by dust from Africa. Imagine a wave crashing on a rocky shore in California. As it crashes, it throws a fine spray into the air. The water in the spray evaporates almost instantly. But what is left behind? A microscopic crystal of salt, impossibly small, impossibly light. This tiny grain of sea salt is lifted by the breeze and begins its own ascent. A tiny, crystalline memory of the ocean, now floating in the atmospheric sea. Imagine a vast pine forest in the mountains of Colorado. It releases pollen into the air, tiny, intricate grains designed to carry life. Some of this pollen is lifted high above the trees, joining the atmospheric drift. Imagine a farmer plowing a field in Kansas, turning over the rich, dark soil. The finest particles of that soil are cast into the wind, or a distant volcano, erupting with great force, spewing a fine ash high into the stratosphere, or even a tiny meteor, burning up as it enters our atmosphere, leaving behind a microscopic trail of cosmic dust. This is the secret ingredient. The air is never empty. It is filled with this fine, invisible dust of the world. It is a thin soup of salt, soil, ash, pollen, and dust. And these particles, these tiny specks of solid matter, are the invitation the water vapor has been waiting for? They are the gathering places, the community centers of the sky. Now, picture one of our slow, cold water molecules. It drifts aimlessly in the saturated air. It is ready to connect, but it doesn't know how. And then, it bumps into one of these particles, a tiny crystal of sea salt. Perhaps the salt is hygroscopic, meaning it loves water. It actively attracts it. The water molecule doesn't just bump into it, it sticks. It has found a home. It has found an anchor. And then, a second water molecule, drifting by, sees this new community and joins it. Then a third, and a fourth. A microscopic accretion begins. One by one, the shy water molecules overcome their hesitation and join the gathering, drawn to the solid anchor at its center. One becomes 10, 10 become 100, 100 become 1,000. A tiny, perfect sphere of liquid water begins to form, with a microscopic speck of the earth at its very heart. A droplet has been born. This is the moment of condensation. It is the breathtaking instant of transformation from the invisible to the visible. It is a ghost materializing. It is a thought becoming an object. And it is happening not just once, but trillions upon trillions of times, all at once. Throughout our rising, cooling parcel of air, every available anchor is being claimed. On a speck of dust, on a grain of pollen, on a crystal of salt. The water vapor is letting go of its gaseous form and embracing its liquid nature. What was once a clear, transparent bubble of air is now becoming cloudy. It is a slow, magical bloom. First, a faint haziness, a slight dimming of the blue sky beyond. Then, the haze thickens, coalescing into something more substantial. The edges begin to define themselves. A shape begins to emerge from the formlessness. An object is being woven right there in the sky, out of nothing more than water, dust, and cold. A cloud is not a single object. It is a multitude. It is a floating city of these tiny droplets, each one a perfect sphere, each one with a tiny particle of the earth at its core. These droplets are so small it would take 1,000,000 of them, gathered together, to make a single average raindrop. They are impossibly light, more like motes of dust in a sunbeam than drops of water. They are so small and so light that even the slightest upward breath of air is enough to keep them suspended, to keep them from falling. They are floating, not because they are weightless, but because they are held in a delicate, perfect balance between the pull of gravity and the lift of the air they reside in. As you rest here, imagine this process. Imagine the quiet, patient gathering. See the invisible becoming visible. It's a profoundly peaceful, creative act. It is the universe revealing one of its most beautiful secrets. The cloud is the physical manifestation of the air's memory. It is the story of the ocean, the story of the forest, the story of the desert, all written in a script of liquid water, held up for all of us to see. Every cloud you have ever seen owes its existence to this trinity of factors: the cooling of the air, the presence of the invisible water vapor, and the tiny, solid anchors on which the droplets can form. Without any one of these, the sky would be perpetually, endlessly clear. So the next time you look up and see a cloud, know that you are not looking at a simple white object. You are looking at a community, a vast floating metropolis of water droplets, each one formed around a microscopic traveler from the world below. That cloud might be part African dust, part Pacific salt, part Canadian pollen. It is a testament to the interconnectedness of things, a visible reminder that the earth and the sky are not separate entities, but are in a constant, intimate dialogue. The earth offers up its dust and its water, and the sky receives them, weaving them into these ephemeral, breathtaking shapes. This is the breath of condensation. It is the exhale of the rising air, a visible sigh in the cold. The journey from the unseen to the seen is now complete. The potential has been realized. The secret is out. And now, floating in the high, quiet air, a new creation rests, waiting to be shaped by the winds, waiting to tell its own unique story. A cloud has been born. A cloud has been born. A community of countless tiny water droplets, each one anchored to a speck of the earth, now floats in the cold, high air. But what form will it take? The sky is a grand canvas, and the winds and energies that move through it are the artists. A cloud is not just a cloud, it is a specific expression of the conditions that created it. And perhaps the most familiar, most friendly of all these expressions is the one we will visit now, the cumulus cloud. This is the cloud of childhood daydreams. It is the cloud you would draw as a child, the puffy cotton ball shape that signifies a bright and cheerful day. When you think of a perfect summer afternoon, this is the cloud that likely drifts through the landscape of your memory. Cumulus. The word itself sounds soft, like something you could rest your head upon. They are the great, gentle beasts of the sky, the floating mountains, the celestial ships on an endless sea of blue. Let us build one together, in our minds. Our journey starts, once again, on the warm ground. It is a summer's day. The sun has been warming a field, or perhaps a large, dark parking lot, or a sun-drenched island in a blue sea. An invisible bubble of warm, moist air, a thermal, has detached itself from the surface and has begun its great ascent. It rises, silent and unseen, through the cooler air. As it rises, it expands and cools. Just as we discussed, it climbs higher and higher, carrying its invisible cargo of water vapor. And then, it reaches that magical altitude, that specific level in the sky, determined by the day's unique temperature and humidity, where the dew point is met, the threshold, and in that moment, the great unveiling begins. Condensation happens, the water vapor, finding its courage on the backs of tiny dust and salt particles, transforms into liquid droplets. And because this is happening in a rising column of air, the cloud that forms has a distinct and beautiful shape. Look at it now. As it begins to form, its bottom is remarkably flat. It looks as though it is resting on an invisible glass table. This flat base is the cloud's birth certificate. It is a perfect visual marker of that condensation level, the exact altitude where the invisible air became a visible cloud. Below that line, the water is a gas. Above that line, it is a liquid. It is a floor, not for the cloud to rest on, but from which the cloud can grow. And how it grows. The thermal, the bubble of air, continues to rise. It pushes up into the cloud it has just created, feeding it more moisture from below. This continued upward energy is what creates the magnificent, billowing tops of a cumulus cloud. It's like watching bubbles in a pot of simmering water. New bubbles of air push up into the main body of the cloud, creating towers and turrets, canyons and valleys. The top boils and churns in slow motion, a silent, majestic explosion of creativity. It looks like a mountain of whipped cream, a giant head of cauliflower, constantly changing, constantly evolving. Its edges are sharp and clear, a brilliant, dazzling white against the deep blue of the sky. This bright whiteness is the collective reflection of the sun's light. Each of the trillions of tiny spherical water droplets acts as a perfect little mirror. When the sun's light hits the cloud, it isn't absorbed, it's scattered in every direction. And when all the colors of the light are scattered equally, the result is the purest, brightest white. That is why the cumulus cloud seems to shine with its own inner light. It is a beacon of reflected sunlight. Now, just relax and watch this cloud. It is a fair weather cloud, a sign that the atmosphere is relatively stable. It floats by, pushed along by the gentle winds of the upper air. It is not a harbinger of storms, but a companion to a peaceful afternoon. It is an object of meditation, and as you watch it drift, your mind begins to do something wonderful and innate. It begins to play. You look at the billows and bumps, the shadows and highlights, and you begin to see things. That particular cloud, the one drifting by now, its top looks like a dragon's head with a long trailing tail of mist, and the one behind it, that one is unmistakable. It is a great, tall ship with billowing white sails, sailing on that ocean of blue. You see faces in profile, animals at rest, maps of imaginary continents. This is the game of pareidolia, the human tendency to see familiar patterns in random shapes. The sky, with its endless parade of cumulus clouds, is the greatest canvas for this game. Let's play for a moment. Look at that cluster of towers on the cloud to your left. See how one juts out, like the snout of a friendly dog, and the two softer bumps above it. Those are its ears, and the shadow underneath. That is its open, panting mouth. It drifts by, a loyal companion in the sky, and now it changes. The wind shears off the snout, and the dog becomes a rabbit, or perhaps a resting lamb. The shapes are fleeting, transient, a reminder that nothing in nature is static. It is a private art show, performed just for you. It's a gentle invitation from the universe to use your imagination, to find the poetry and the physics. A cumulus cloud has a life. It is born from the warm earth. It lives its life drifting in the sun, and then it dies. Its death is as gentle as its birth. Perhaps the thermal that was feeding it from below dissipates. The upward flow of warm, moist air ceases. Or perhaps the cloud drifts into a region of drier air. The surrounding air becomes thirsty, and it begins to drink the cloud's droplets. The process of evaporation begins. One by one, the tiny water droplets let go of their liquid form and transform back into invisible vapor. The sharp, brilliant edges of the cloud begin to soften. They become hazy, indistinct. The cloud starts to look tattered, like old lace. It thins out, becoming more and more transparent. You can start to see the blue of the sky right through its center. And then, in a final, quiet sigh, it is gone. It has exhaled its water back into the great atmospheric ocean. It has dissolved, leaving no trace, returning its borrowed water to the air, ready for the cycle to begin again somewhere else. Some cumulus clouds live for only a few minutes, ephemeral puffs of white. Others, the larger ones, can drift for an hour or more, majestic and slow, before they too fade back into the invisible. To see a field of these clouds, a sky full of them, is to see the atmosphere breathing. Each cloud is a visible manifestation of a rising column of air, an exhale from the ground below. The blue spaces in between are the places where the air is gently sinking, completing the cycle. The sky becomes a landscape of rising and falling, of visible and invisible, a dynamic and living system. The flat bottoms of the clouds, all resting at the same invisible altitude, create a powerful sense of perspective, giving the sky a depth and a structure it would otherwise lack. It truly becomes a ceiling to our world, decorated with these soft, floating sculptures. So the next time you find yourself with a moment of peace on a sunny day, lie back on the grass, watch the cumulus clouds, watch their birth, their slow and drifting life, their gentle fading death. Do not see them as mere objects, but as processes. See them as the visible tips of invisible fountains of air, fountains that are rising from the very ground you are lying on. Appreciate the brilliant white of their sun-drenched tops and the cool, gray shadows of their flat bottoms. Let your mind wander and find your own private menagerie of animals and faces in their forms. In their simple, peaceful existence, they teach us a lesson. They are a reminder of the beauty of the transient. They are perfect in their brief moment, and they let go without a struggle, dissolving back into the whole. They are a physical representation of a deep, peaceful breath. The earth exhales, and a cloud is born. The sky inhales, and the cloud vanishes. And in between, for a few precious moments, we are gifted with its gentle, floating, ever-changing beauty. It is the signature of a happy sky. We have spent our time with the friendly, puffy cumulus clouds, those cotton ball companions of a summer's day. They live in the lower, warmer levels of the atmosphere, close to the world of liquid water and rising thermals. But now, our journey must take us higher, much higher. Let us leave the bustling lower atmosphere behind and ascend into the quiet, frigid, and rarefied realm at the very top of our weather-filled world. The highest reaches of the troposphere, up here, 5, 6, even 8 miles above the Earth. The rules are different. The air is painfully thin, and the cold is profound, a deep and abiding chill that never leaves. It is a world perpetually locked in deep winter. Water here cannot exist in the way we are used to. It cannot be the soft, liquid droplet of a cumulus cloud. The cold is too intense. Here, any moisture that reveals itself must do so not as a liquid, but as a solid. Here, we enter the kingdom of ice. And in this kingdom, a new and entirely different kind of cloud reigns. It is the cirrus cloud. The word cirrus comes from the Latin for a curl of hair, a ringlet, and no name could be more fitting. These are not the bulky, solid-looking mountains of the lower sky. They are ethereal, ghostly, and impossibly delicate. They are the thinnest of veils, the most delicate of brushstrokes against the deep, dark blue of the upper sky. They are wisps of pure white, so thin you can often see the sun or moon shining clearly through them. The story of their birth is different from that of the cumulus. While a cumulus cloud is born from a distinct, powerful bubble of rising air, a cirrus cloud is often formed by a much slower, more widespread, and gentle lifting of a vast layer of air. Or they can be the remnants of other, larger clouds, like the mighty thunderstorms that punch their way up to this altitude. The tops of these storms, sheared off by the powerful winds, can spread out and become vast fields of cirrus. But the most fundamental difference is in the transformation itself. In the lower sky, we spoke of condensation, where water vapor becomes liquid. Up here, in the intense cold, something even more magical happens. The process is called deposition. A water vapor molecule, floating in the frigid air, doesn't even pass through a liquid state. It transforms directly from a gas into a solid crystal of ice. It finds a tiny nucleus, a speck of cosmic dust, or a microscopic particle of clay, and in an instant, it remembers its crystalline form. It builds itself, molecule by molecule, into a perfect six-sided lattice. It becomes a tiny, hexagonal jewel of ice. A cirrus cloud is a community of these jewels. It is a floating, drifting collection of trillions of microscopic ice crystals. And because they are solid and crystalline, not liquid and spherical, they look entirely different. They are not puffy, they are fibrous. They are not clumpy, they are streaky. Look up now, in your mind's eye, to this high, cold place. See how they are formed. A faint patch of white appears. a hazy area where the ice crystals are first beginning to take shape. But up here, the winds are fierce. This is the realm of the jet stream. Great, fast-flowing rivers of air that circle the globe at hundreds of miles per hour. As these tiny ice crystals form, they are immediately caught by these powerful winds. They are stretched, pulled, and drawn out into long, delicate filaments. This is what gives cirrus clouds their signature, wispy appearance. You are not just seeing a cloud, you are seeing a visible record of the wind. The long streaks and fibers are painting a picture of the invisible currents that are shaping them. They look like strands of fine, white hair being combed by an unseen hand. They are often called mare's tails for this very reason, looking like the long, flowing tails of celestial horses galloping across the sky. These mare's tails, or Cirrus unsinus as they are known, have a particular beauty. They are often shaped like a delicate hook or a comma. This shape tells a story. The thicker, clumpier part of the hook is where the ice crystals are forming. The long, streaky tail is where those crystals are falling, caught by winds of a different speed at a slightly lower altitude, and sublimating, turning from ice back into invisible vapor as they descend. The entire cloud is a dynamic process of creation, falling and dissipation, all drawn out for you to see. Because of their great height, cirrus clouds are often the first to catch the light of the rising sun and the last to hold it in the evening. Long after the sun has set for you on the ground, and the cumulus clouds below have turned to dark gray shapes, the cirrus clouds high above are still bathed in sunlight. They catch the long, red wavelengths of light and set the high sky ablaze with colors of pink, orange, and fiery red. They are the canvases for the sky's most spectacular sunsets, a final, beautiful farewell to the day's light. But cirrus clouds are more than just beautiful. They are messengers. They are the advance scouts of the atmosphere, because they are formed by that slow, widespread lifting of air that often precedes a weather front. Their appearance in a clear blue sky is often the very first sign that the weather is about to change. Imagine a clear, calm day. You look up and see the first few lonely wisps of cirrus appearing on the western horizon. They are thin, delicate, hardly there at all. But as the hours go by, they become more numerous. They begin to thicken, spreading out from streaks into a thin, translucent sheet that covers more and more of the sky. This progression, from isolated wisps to a thickening, spreading veil, is the sky telling you a story. It's a gentle warning that a warmer, moister air mass is approaching, gliding up and over the air you are currently in. A day or so after the first cirrus appear, the clouds will have lowered and thickened, and rain may be on the way. They do not bring the weather themselves, but they are its herald, its announcement. And these ice crystals have another piece of magic to share. Because they are tiny, hexagonal prisms, they do wonderful things with light. When a cirrus cloud is thin enough and positioned just right between you and the sun or moon, these trillions of tiny, aligned ice crystals can bend the light in a very specific way. They can create a perfect luminous ring around the sun or moon. This is a halo. A halo is one of the sky's most serene and beautiful phenomena. It is not a rainbow. Its colors are much fainter, if visible at all, and it is a full circle of light. It is your own personal ring of light, created by the ice crystals bending the sun's rays at a precise 22-degree angle before they reach your eyes. To see one is to be in the presence of a great and silent piece of atmospheric optics. And, like the appearance of the cirrus clouds themselves, a halo is often another sign that rain is on the way, as it confirms the presence of that high, thin layer of ice crystal clouds that precedes a storm. There is an old piece of weather wisdom: ring around the moon. Rain is coming soon. It is a piece of folklore that is grounded in the beautiful science of the cirrus cloud. So, let your mind rest in this high, cold, quiet place. It is a world of sharp, crystalline beauty, so different from the soft, liquid world below. The clouds here are not objects. but process is made visible. They are the brushstrokes of the jet stream, the crystallized breath of the upper air. They are the messengers of changing weather and the artists of the sunset. The next time you see them, those high, thin, wispy veils, appreciate their delicacy. Know that you are looking at a cloud made not of water, but of countless tiny jewels of ice, floating 8 miles above you. Watch how they are stretched and pulled by winds you will never feel. If they are thickening and spreading, read the story they are telling about the weather to come. And if the conditions are right, look for that silent, perfect ring of light, the halo, a geometric gift from the sky. The cirrus cloud is a reminder that the sky has many moods, many layers, and that its most delicate and fragile-looking creations are often the ones that live in its most extreme and powerful realms. We have soared to the highest, coldest reaches of the sky, dwelling among the icy, wispy veils of the cirrus cloud. Now, it is time to descend. Let us journey back down, past the mid-levels, past the realm of the puffy, fair-weather cumulus, and come to rest in the very lowest level of the atmosphere, just above the treetops, just above the roofs of the city. Here, in this low, close to the earth space, we find a different kind of cloud, with a different kind of mood. We enter the quiet, contemplative world of the stratus cloud. Stratus. The word means to spread out or to flatten. And that is exactly what this cloud does. It is not a distinct object like a cumulus cloud, nor a delicate, streaky wisp like a cirrus. A stratus cloud is a sheet. It is a layer. It is a vast, uniform, and often featureless blanket that is drawn across the entire sky on a day ruled by stratus clouds. You look up and you do not see a blue canvas decorated with white shapes. You see only the cloud itself. It can stretch from one horizon to the other, a seamless, uninterrupted ceiling of soft gray. To some, this might seem gloomy or sad. It is the classic overcast day. But we, as sleepy scientists, can find a different perspective. A stratus day is not an empty day. It is a day of profound calm. It is as if the sky has lowered a gentle lid upon the world, quieting the noise, softening the harsh light, and inviting everything below to rest. It is a celestial blanket, tucked in around the shoulders of the landscape. The formation of a stratus cloud is a story of stability. Unlike the cumulus, which is born from energetic, bubbling thermals of rising air, the stratus cloud is born from tranquility. It often forms when a large, stable layer of moist air is gently lifted, all at once, over a wide area. There is no churn, no boiling, no dramatic convection. It is a slow, methodical, and peaceful ascent of an entire sheet of air. As this whole layer rises, it cools, and when it reaches its dew point, condensation occurs across the entire sheet at once. The result is not a collection of individual clouds, but one single, vast, and continuous cloud. Sometimes, stratus clouds are born from a different, even quieter process. Imagine a clear, calm night. The Earth, which was warmed by the sun all day, begins to radiate that heat back into space. The ground cools, and it, in turn, cools the layer of air resting just above it. If that air is moist enough, it can cool all the way to its dew point, and a layer of cloud, a stratus, forms right there, near the ground, born from the coolness of the night. But perhaps the most intimate way to experience a stratus cloud is to walk inside one. Because when a stratus cloud forms at, or sinks to, ground level, we give it another name. We call it fog. Fog is not some mysterious, separate phenomenon. It is quite simply a cloud that you can touch. It is a stratus cloud that has decided to hug the Earth. To be inside fog is to be inside a cloud, and it is a truly magical experience for the senses. Let's walk into it. You stand at the edge of a field as a thick bank of fog rolls in. The first thing you notice is the change in the air. You feel a cool dampness on your skin. a fine, almost imperceptible mist that clings to your hair and clothes. The smell of the air changes. It becomes thick with the scent of damp earth, wet leaves, the clean smell of the water itself. And then the world begins to disappear. The distant trees, which were clear moments ago, fade into gray silhouettes and then vanish entirely. The sound of the world changes. Sound waves are scattered and absorbed by the trillions of tiny water droplets, and everything becomes muffled, quiet, and strangely close. A bird calling from a nearby tree sounds sharp and clear, while the distant drone of traffic is erased completely. The world shrinks to your immediate surroundings. Your senses, which are used to reaching out for hundreds of yards, are now drawn in, creating a profound sense of intimacy and solitude. Walking through fog is like walking through a dream. Familiar landscapes become strange and new. A simple path through the woods becomes a mysterious corridor, each tree emerging from the mist just a few feet before you, and vanishing again as you pass. Streetlights, at night, no longer cast sharp pools of light. Instead, they create soft, glowing orbs, their light diffused and scattered by the cloud you are moving through. It is a world without sharp edges, a world without long distances. It is a world of soft focus, of quiet contemplation. You are not just looking at a cloud, you are a part of it. You are breathing it. It is all around you. When the sun begins to rise on a foggy morning, a new magic occurs. The fog, this ground-hugging stratus cloud, begins to warm. It starts to lift. The process of dissipation begins, but it happens from the ground up. You might see the fog begin to thin around your feet, revealing the grass, while your head is still in the cloud. Then, the cloud's base lifts above you, and you find yourself under a low, gray ceiling. You have just witnessed, from the inside out, the transformation of fog into a low-lying stratus cloud. You have stood on the earth and watched a cloud rise off the ground around you. The light on a stratus day is special. With the sun hidden behind this thick, uniform blanket, there is no direct sunlight. There are no harsh shadows. The light comes from everywhere at once. It is a soft, diffused, and even light. It's the kind of light that painters love, as it allows the true colors of the landscape to show themselves, rich and saturated, without the glare of the sun washing them out. A red barn on a stratus day seems redder. The green of a forest seems deeper. The world feels gentle on the eyes. It is a restful light, asking for nothing. These clouds are not usually associated with heavy weather. Their stability means they don't have the powerful updrafts needed to create large raindrops. But they are not always dry. They can produce a fine, misty precipitation known as drizzle. It's a rain so light you barely feel the individual drops. It's more like a thickening of the fog, a fine spray that slowly and patiently dampens every surface, leaving the world glistening and refreshed. It is the cloud weeping in the most gentle way imaginable. So let us not think of the stratus cloud as a sign of a gloomy day. Let us reframe it. It is a sanctuary. It is a pause button for the world. On a bright, sunny, cumulus-filled day, the world feels expansive, energetic, and full of possibilities. On a stratus day, the world becomes intimate, quiet, and introspective. It's a day for a warm drink, for reading a book, for listening to the quiet sounds of your own home. The stratus cloud provides the perfect excuse to slow down, to turn inward, and to rest. It is a blanket, woven from water and air, tucked gently over the land, giving everything beneath it a chance to be still. It is the sky in a meditative mood. We have met the clouds of fair weather and high, icy veils. We have rested under the calm, gray blanket of the stratus. The clouds we have come to know so far have been, for the most part, passive observers. They have drifted, changed, and dissolved, decorating the sky with their ephemeral beauty. But now we must turn our attention to the clouds that are not content to simply float. We must meet the clouds of action, the clouds that complete the cycle. These are the clouds that give back the water they have so carefully gathered. These are the bringers of rain. To find them, we look for a special name, a Latin word that acts as a key nimbus. When you see nimbus attached to the name of a cloud, you know it has reached a point of critical mass. It is a cloud so full of moisture that it can no longer hold it. It is a cloud ready to connect the sky to the earth with life-giving water. There are two great nimbus clouds, two very different personalities that deliver the rain. One is a gentle nurturer. The other is a powerful, dramatic force of nature. Let us first meet the gentle one, the nimbostratus. Remember our friend, the stratus cloud? That low white gray uniform blanket that tucks the world in and encourages it to be calm. Imagine that blanket on a day when the atmosphere is particularly full of moisture. The gentle, widespread lifting continues, and the stratus layer grows deeper and thicker and heavier. It lowers, and its soft gray color deepens to a dark, moody slate. This is nimbostratus. It is the stratus cloud that has decided to act. A nimbostratus sky is the epitome of a rainy day. It is a thick, seamless, and featureless ceiling, often so thick that it completely obscures the sun. The light beneath it is dim and shadowless, a deep twilight that can last all day long. There is a feeling of immense weight in the air, a profound stillness, as if the whole world is holding its breath, waiting. And then, it begins. The rain from a nimbostratus cloud is not a sudden downpour. It is a gradual, steady, and persistent release. It might start as a fine drizzle, that misty spray we felt from the stratus, but it slowly and surely intensifies into a true rain. The droplets are small to medium-sized, and they fall with a steady, hypnotic rhythm. This is the sound that has lulled so many to sleep. The steady drumming on the roof, the soft shushing sound as it falls on the leaves of a forest, the gentle tapping against a window pane. It is a sound of comfort, of security. The world outside is being washed clean, and you are safe and dry, listening to the music of the sky. This is a rain that soaks deep into the earth. It is not a violent rain that runs off the surface, but a patient, nurturing rain that has time to seep down, to replenish the groundwater, to give a long, slow drink to the thirsty roots of trees and plants. A nimbostratus. Rain can last for hours, sometimes for days. It is the expression of a very large, very stable, and very moist air mass. The cloud itself is vast, covering hundreds, even thousands of square miles. And within this deep, dark cloud, the process of creating rain is a slow and patient one. The countless tiny cloud droplets are gently stirred by weak air currents, and they begin to collide and combine. This process is called coalescence. Two tiny droplets become one slightly larger one. That larger one collabs with another, and so on. It is a slow, statistical dance of accumulation. It takes millions of these tiny cloud droplets to form a single raindrop. And the nimbostratus cloud provides the perfect environment, stable and long-lasting for this process to occur. Eventually, the combined drops become heavy enough to overcome the weak updrafts, and they begin their long, steady fall to the earth. But there is another bringer of rain, a cloud with a much more dramatic and powerful personality. This cloud is born not from stability, but from immense, explosive instability. It is the king of all clouds. It is the cumulonimbus. Our story begins with a familiar friend, the puffy, white cumulus cloud of a summer's day. But on some days, the atmosphere is different. It is charged with energy. The bubble of warm, moist air that rises from the ground is not just warm, it is hot and extremely humid. The atmosphere above it is unusually cold. This tremendous contrast creates a powerful, violent buoyancy. The cumulus cloud, instead of drifting peacefully, begins to grow with astonishing speed. It is a cumulus cloud on a mission. Fueled by the powerful, churning updraft at its core, it grows upwards and upwards and upwards. It pushes through the lower levels of the atmosphere, growing from a friendly puff into a towering castle, a great mountain of a cloud. We call this a towering cumulus, or cumulus congestus. It is the adolescent stage of a thunderstorm. But it does not stop there. The updraft is relentless, a raging elevator of air moving at speeds of up to 100 miles per hour. It pushes the cloud higher and higher into the frigid upper reaches of the troposphere, the realm of ice crystals we visited with the cirrus clouds. The top of the cloud, which was once a boiling, cauliflower-like dome of water droplets, now enters this freezing region. The droplets become supercooled, and they begin to freeze, turning into ice. The top of the cloud transforms, its sharp, boiling edges softening and becoming fibrous and wispy. The relentless updraft finally reaches the very top of the troposphere, a layer called the tropopause, which acts as a lid. The updraft cannot punch through this lid, so it is forced to spread out horizontally. This creates the iconic, flat-topped anvil shape of a mature cumulonimbus cloud. The cloud has reached its full and terrible majesty. It is a single cloud that can be 10 miles high, from its low, dark base to its high, icy anvil. It is a self-contained weather-generating machine. To be on the ground as one of these giants approaches is to witness true power. The sky darkens ominously. The air, which was hot and humid, suddenly cools as the cloud's downdraft begins to reach the ground. The wind picks up, blowing out from the storm. And then the rain comes. It is not the gentle, steady rain of the nimbostratus. It is a deluge. The raindrops are enormous, born from a violent process of collision in the heart of the storm, where ice crystals and supercooled water droplets are churned together, growing rapidly. The result is a torrential downpour, a wall of water that can flood streets in minutes. And then comes the light and the sound. Within the turbulent cloud, the violent collisions of ice crystals and water droplets strip electrons, creating an immense separation of positive and negative electrical charge. The cloud becomes a vast celestial battery. When the charge becomes too great to bear, the sky seeks to balance itself. It finds the quickest path and releases the energy in a cataclysmic, brilliant spark. This is lightning, a channel of plasma hotter than the surface of the sun, flashing for an instant, connecting the cloud to the ground or another part of the cloud. And the sound that follows is not the voice of an angry god. It is pure physics. The lightning bolt heats the air in its narrow channel to an incredible temperature, causing the air to expand explosively, faster than the speed of sound. This creates a powerful shockwave. That shockwave is what you hear as thunder. It is the sound of the air ripping apart and collapsing back in on itself. If the lightning is close, the thunder is a sharp, deafening crack. If it is far away, the sound waves bounce off the landscape and the clouds, and you hear it as a long, low, rumbling growl, the deep voice of the cloud itself. It is the sky's great heartbeat. A thunderstorm is the atmosphere trying to right itself, trying to release an immense amount of built-up energy. It is a violent and awe-inspiring process, but it is also a cleansing one. The heavy rain washes the air clean of dust and pollutants, and the lightning converts nitrogen in the air into a form that plants can use, a natural fertilizer. So we have the two nimbus clouds, the nimbostratus, the gentle, patient nurturer, giving a long, slow drink to the earth, and the cumulonimbus, the powerful, dramatic king of clouds, resetting the atmosphere with its violent energy, its cleansing rain, and its electric heart. Both are essential. Both are a critical part of the great cycle, returning the water that began its journey in a sunbeam on the ocean, back to the earth from which it came. We have explored the forms and personalities of the clouds, from the friendly cumulus to the dramatic cumulonimbus. We have understood their birth, their life, and their ability to return water to the earth. But now we must turn our senses to one of their most magical and breathtaking qualities, their color. A cloud is rarely just a shape. It is a vessel of light. It is a canvas upon which the sun and the atmosphere collaborate to create art. Why is a cloud white? Why is its base gray? And how, at the beginning and end of each day, does it transform into a spectacle of impossible, fiery color? Let us begin with the most fundamental question. Why, on a typical day, is a cloud a brilliant, snowy white against a blue sky? The answer to that question begins with the sky itself. The deep blue of a clear sky is the result of a process called Rayleigh scattering. The individual molecules of nitrogen and oxygen that make up our air are incredibly small, and they are the perfect size to intercept and scatter the shorter, higher energy wavelengths of light, namely blue and violet light. As sunlight streams into our atmosphere, the blue light is scattered in every direction, filling the sky with its color from every angle. The sky is blue because the air itself is a blue filter. But when a cloud forms, the rules of the game change entirely. A cloud is not made of individual tiny gas molecules. It is made of water droplets. And these droplets, while microscopic to us, are gargantuan compared to a molecule of air. They are so much larger that they are no longer selective about which color of light they scatter. They are democratic. They treat all colors equally. This different process is called Mie scattering. Imagine a single beam of sunlight entering a cloud. This beam, as we know, contains all the colors of the rainbow, all mixed together to form what our eyes perceive as white light. When this beam hits the first water droplet, it is scattered. Red light goes one way, blue another, green yet another, but it immediately hits another droplet and is scattered again, and again, and again. Within the dense, chaotic community of a cloud, the light is bounced and ricocheted trillions of times in a fraction of a second. It is a riot of reflection and refraction. The result is that by the time the light emerges from the cloud and travels to your eye, it is a complete and utter jumble of all the colors, all mixed back together again. All the wavelengths red, orange, yellow, green, blue. Violet arrive at your eye in a chaotic, simultaneous chorus. And when our brain receives this signal, this blast of all colors at once, it interprets it as white. A cloud is white for the same reason that a pile of sugar is white, or a pile of salt is white, or snow is white. Each individual crystal of sugar or salt or ice is transparent, but when they are piled together, they create a multitude of surfaces that scatter light in every direction, mixing all the colors back together into a brilliant white. So, a cloud's whiteness is not a color it possesses. It is the color of all light, returned to you. It is a perfect mirror, reflecting the full spectrum of the sun. It is an object of pure light. So, if a cloud is made of white light-scattering droplets, why is its bottom so often gray? Why does the belly of a mighty thunderhead look so dark and ominous? The answer is simple, and one you already know from your own experience. The answer is shadow. A cloud is not a flat, two-dimensional object. It has immense thickness. The top of a cumulus cloud, bathed in direct sunlight, is scattering that brilliant white light in all directions, including back up into space and out to the sides. It is so effective at scattering light that very little of the sunlight can actually penetrate all the way through the cloud to its base. The cloud is casting a shadow upon itself. The gray you see is not a different substance. It is not a different color of water. It is simply the absence of light. The thicker and denser the cloud, the more water droplets there are to scatter the light, and the less light makes it to the bottom. A thin, wispy cumulus cloud might have a base that is only a slightly off-white color, but a massive nimbostratus or cumulonimbus cloud, many miles thick, can block almost all of the incoming light, making its base appear as a dark, almost black slate. The color of a cloud's base is a direct indicator of its vertical thickness, and therefore its potential to hold and deliver rain. It is the cloud's own shadow, a hint at the sheer density of water it holds within. And now, we arrive at the grand performance, the daily miracle that happens at the edges of the day, the sunrise and the sunset. This is when the clouds, the atmosphere, and the sun align to put on their most spectacular show. To understand this, you must picture the journey of the sunlight. At midday, the sun is high overhead. Its light travels a relatively short, direct path through the atmosphere to reach your eyes. The air scatters some blue light, making the sky blue, but most of the light gets through unaltered, so the sun appears as a brilliant yellowish white. But at sunrise or sunset, the sun is at the horizon. Its light is no longer taking a direct path. To reach you and to reach the clouds above you, it must travel a much, much longer path, skimming sideways through the Earth's atmosphere. It is traveling through hundreds of miles more of air than it does at noon. And on this long, arduous journey, it encounters far more of those tiny, blue scattering air molecules. Imagine the beam of light as a traveler on a long road. At every step of the journey, it must pay a small toll of blue light. After a few miles, much of its blue light is gone, scattered away. As it travels further, it starts to pay a toll of green light. The only colors with long enough wavelengths, with enough resilience to make it all the way through this long atmospheric journey, are the reds, the oranges, and the yellows. So, the light that finally arrives at the end of this journey, the light that reaches your eye and illuminates the clouds above you, is no longer white light. It is a light that has been filtered by the atmosphere. It is the warm, golden, and reddish light of sunset. Now, think of the clouds. These clouds, which at midday were brilliant white mirrors of the full spectrum, are now being lit by a different kind of light source. They are no longer being lit by a white sun. They are being lit by a red sun. And the clouds, being the perfect, non-selective mirrors that they are, simply reflect the light that they are given. The cloud becomes a movie screen. The atmosphere is the projector, creating the colored light, and the cloud is the perfect, giant, three-dimensional screen upon which the movie is shown. The cloud itself is not turning red or pink. It is being painted. It is being set ablaze by the last warm rays of the dying day. And what a painting it is. You watch as a bank of high cirrus clouds begins to catch the light. First, they turn a pale yellow. Then, as the sun sinks lower and the light becomes even more filtered, they deepen to a burnished gold, then a fiery orange. The undersides of lower altocumulus clouds can look like they are on fire, a rippling ceiling of molten lava, a mighty cumulonimbus anvil, catching the last rays, can look like a cosmic mountain of rose-colored gold. The spectacle does not end when the sun disappears below the horizon. For a while, its light can still travel up and hit the highest clouds. This is the afterglow. This is when the colors often deepen into the most profound crimsons and reds, before finally fading into soft pinks and gentle purples. This twice-daily performance is a perfect collaboration. Without the atmosphere to filter the light, the setting sun would just be a white disk that disappears, and the clouds would remain white until they faded to black. Without the clouds to act as a screen, the beautiful red light would just stream out into space, unseen. It is the combination of the three elements, sun, atmosphere, and cloud, that creates the magic. Each sunset is a unique work of art, dictated by the type and placement of the clouds, and the amount of dust and haze in the air to scatter the light. So, the next time you are gifted with a spectacular sunset, know what you are seeing. You are seeing a lesson in physics, a masterpiece of optics. You are witnessing the long journey of light and seeing only the resilient travelers who made it all the way to the end. The clouds are not the source of the beauty, but the canvas that reveals it, making the invisible visible one last time before the world settles into the quiet darkness of the night. We have journeyed far and high, explored the many personalities of the clouds, and reveled in the artistry of the light they command. But a quiet, logical question may have been floating in the back of your mind this whole time. It is a question that seems, on its surface, to defy everything we see. We have spoken of clouds as being made of water of nimbus stratus, clouds carrying the weight of entire rivers, of thunderheads containing hundreds of thousands of tons of water. So the question is simple, yet profound. Why do they float? If a cloud is a massive object made of water, why doesn't it just fall out of the sky? It is a wonderful question, because the answer reveals that a cloud is not what it appears to be. It is not a solid object, but a delicate, dynamic, and perfectly balanced performance. The answer lies in two parts: the nature of the droplets themselves, and the nature of the air that holds them. First, let us consider the building blocks. We call them droplets, but this word is misleading. It makes us think of a drop of water from a faucet, or a single raindrop. A cloud droplet is something else entirely. It is impossibly small. The average cloud droplet is about 20 micrometers in diameter. That is so small that it would take 50 of them, lined up side by side to equal the thickness of a single human hair. It would take more than 1 million of these tiny droplets, all merged together, to form one average-sized raindrop. Because they are so incredibly small, they are also incredibly light. They are like dust. Think of a quiet, sunlit room. You can see tiny motes of dust dancing in the sunbeam. They seem to hang in the air, suspended, almost weightless. Are they truly floating? Not quite. They are, in fact, falling. But they are so small and light that their terminal velocity, the fastest speed they can reach as they fall, is incredibly slow. Air resistance, the friction of the air itself, has a massive effect on them, holding them back, slowing their descent to a lazy, almost imperceptible drift. A cloud droplet behaves in exactly the same way. It is technically always falling, but its terminal velocity is so slow, a few centimeters per minute, that from our perspective on the ground, miles below, it appears to be perfectly suspended. The friction of the air it is falling through is almost enough to hold it in place. So, part one of the answer is that a cloud is made of trillions of tiny dust-like particles of water, each one falling so slowly that they appear to be floating. But that is only half of the story, because it does not explain how a cloud can last for hours, or how it can grow upwards, seemingly defying gravity. For the second, and most important, part of the answer, we must return to the birth of the cloud. We must remember the great ascent. A cloud is not formed in still, static air. A cloud is a signpost. It is a visible marker for a place where the air is rising. Remember the thermals, the warm sighs of the earth, that create the cumulus. Remember the gentle, not widespread lift that forms the stratus. Remember the violent, churning updraft at the heart of the cumulonimbus clouds are born in and live in rising air. Now picture this. Imagine you have a single, tiny feather. If you drop it in a perfectly still room, it will slowly, gently drift to the floor. But now, imagine you drop that same feather over a heater or a warm vent. The gentle, rising current of warm air will catch it. The feather will not fall. It will hover, dance, and perhaps even be carried higher into the room. The upward force of the rising air is stronger than the downward pull of gravity on the feather. This is precisely what is happening inside a cloud. The trillions of tiny, dust-like water droplets are the feathers. And the updraft, the rising current of air that created the cloud in the first place, is the warm air from the vent. Even a very gentle updraft, one moving at only a fraction of a mile per hour, is more than strong enough to overcome the incredibly slow falling speed of the cloud droplets. So, the cloud is not just sitting there in the sky, it is being actively held aloft. It is riding on a cushion of rising air. The very process that creates the cloud is the same process that keeps it afloat. As long as the updraft continues, the cloud will not fall. In fact, if the updraft is strong, as in a growing cumulus cloud, the cloud will continue to get higher and higher, its top boiling and churning as it's fed by the powerful current from below. This leads us to the final, and perhaps most beautiful, part of the answer. It requires a slight shift in how we think about a cloud. A cloud is not a thing, it is a process. It is not a static object, but a visible manifestation of a dynamic event. Think of a fountain in a garden. You see a beautiful, constant shape made of water. But is it a solid object? Of course not. It is an illusion created by the constant motion of water. Water is being pumped up, arcing through the air, and falling back into the basin, only to be pumped up again. The shape remains, but the water that makes the shape is changing every second. A cloud is like a fountain of air. It is a place in the sky, an area where the conditions are just right for condensation to occur. The updraft continuously pushes new, moist air up into this zone. As the air rises and cools, new droplets form at the base of the cloud, replacing the ones that are there. Within the cloud, droplets are slowly drifting downwards. But the rising air keeps them, and the cloud as a whole, suspended. Often, as droplets drift down toward the bottom of the cloud, they fall out of the main updraft and into the drier, warmer air below the cloud base. And when they hit this warmer air, they evaporate. They turn back into invisible water vapor. Poof. They vanish. So, there is a constant cycle happening. New droplets are born at the top and in the middle of the cloud, while old droplets die by evaporating at the bottom and sides. The cloud's shape, like the fountain's shape, can seem relatively constant for a while, but it is a dynamic equilibrium. It is a place where the rate of condensation is, for a time, greater than or equal to the rate of evaporation. When the updraft dies and the moist air is cut off, the evaporation wins, and the cloud fades away, just as the fountain's shape would collapse if you turned off the pump. This explains the paradox. A cloud can contain tons of water, but that water is distributed among trillions upon trillions of nearly weightless droplets. And this entire community of droplets is held aloft by a rising current of air that is stronger than their individual tendency to fall. It is a breathtaking balancing act, a performance of physics held on a stage that is miles wide. So, when you next look up at a cloud, do not see it as a thing, like a boat on the ocean. See it as a place. Like a waterfall on a river, see it as a visible sign of an invisible process, the constant, graceful, and powerful rising of the Earth's own breath. It is not floating because it is empty. It is floating because it is full of energy, full of rising air, full of life. It is the perfect, delicate balance between the downward pull of gravity and the upward push of the sky. Our journey together is drawing to a close. We have traveled from the sun-warmed surface of the ocean into the vast, invisible sea of the atmosphere. We have ridden the great thermal elevators into the cold, high altitudes. We have witnessed the magical breath of condensation, where the unseen becomes seen. We have met the friendly cumulus, the ethereal cirrus, the calming stratus, and the mighty nimbus. We have been painted with the light of sunset and have understood the delicate, impossible balance that keeps these watery mountains afloat. We have seen how clouds are born and how they live. And now we must witness the final gentle chapter of their story, how they end. The end of a cloud is not a death. It is a transformation. It is a letting go, a return. It is the completion of a circle, and it is as peaceful and as beautiful as every other part of the journey. We call it dissipation, a word that means to scatter, to disappear. And it can happen in several ways. Let us imagine a single perfect cumulus cloud, born on a summer's day. It has lived its life drifting on the breeze, a beacon of brilliant white. But now, the afternoon wanes, the sun sinks lower, and the ground beneath the cloud begins to cool. The rising column of warm air that was the cloud's lifeblood, begins to weaken. The upward push lessens. Without this constant supply of moist, rising air, The cloud's source of new droplets is cut off. The fountain is being turned off. At the same time, the air around the cloud, which may be drier, begins to interact with it. Think of this dry air as being thirsty. It mixes with the edges of the cloud, and it begins to drink the tiny water droplets. The process of evaporation begins to overwhelm the process of condensation. One by one, the droplets on the outer edges of the cloud are given a little nudge of energy from the surrounding air, and they break free from their liquid form. They let go of their anchor, that tiny speck of dust or salt, and they ascend once more into the realm of the invisible. They become water vapor again. You can see this happening. The brilliant, sharp edges of the cloud begin to soften. They grow hazy and indistinct. The cloud starts to look tattered and torn, like a piece of celestial fabric fraying at the seams. It becomes thinner, more transparent. You can begin to see patches of the blue sky through its weakening form. The process is gentle, a slow, silent dissolving. The cloud is exhaling itself back into the atmosphere. It is giving back the water it borrowed. Finally, the last few wisps of visible moisture fade away, and there is nothing left but the blue sky where a mountain of white once stood. The cloud has vanished, returning completely to the invisible ocean from which it was born in the first place. Or imagine our blanket of stratus cloud on a foggy morning. The sun rises higher in the sky. Its rays, growing stronger, begin to warm the top of the cloud layer. This warmth is energy. It is delivered to the topmost droplets, giving them the vigor to leap back into their gaseous state. The cloud begins to dissipate from the top down. At the same time, the sun warms the ground below, which warms the air near the surface, evaporating the cloud from the bottom up. Caught between these two sources of warmth, the stratus blanket thins, breaks into pieces, and scatters, revealing the blue sky and the bright sun of a new day. It has done its work of blanketing the night, and now it gives way. Even the high, icy cirrus cloud must end its life. As its delicate, feathery strands fall from the frigid upper atmosphere, they often encounter lower, warmer, and drier layers of air. As they fall, the tiny ice crystals do not melt, they sublimate. They turn directly from solid ice back into invisible water vapor. This is why the mare's tails often have those hooked shapes that seem to fade into nothingness. You are watching the cloud returning to the atmosphere as it falls. This process of returning to the invisible is the final, crucial step. It ensures that the water is not lost. It is simply being stored again, held in readiness for the next journey. The water vapor that is released from a dissipating cloud over North America might be carried by the great wind currents across the Atlantic, to one day be part of the great ascent that forms a new cloud over Europe. The cycle is global. It is continuous. It is eternal. And what of the clouds that do not dissipate? What of the nimbus clouds, the ones that deliver their water back to the earth as rain or snow? This, too, is a completion of the cycle, just a different path home. Follow a single raindrop, born in the heart of a great nimbus cloud. It falls, joining trillions of others in a life-giving shower. It might land on the leaf of a great oak tree, where it will sit, glistening, before evaporating directly back into the atmosphere, ready to begin its journey again almost immediately. Or it might drip from that leaf and soak into the rich, dark soil of the forest floor. There, it might be drawn up by the roots of a wildflower, becoming part of its structure, part of its life, before being released back into the air through transpiration from its petals. Or perhaps the raindrop lands in a small mountain stream. It will join other drops, and the stream will become a creek, and the creek will flow into a river. The water will travel for days or weeks, journeying through the landscape, giving life to the fish within it and the plants and animals along its banks. And eventually, that river will find its way back to its origin. It will flow into the great, salty expanse of the ocean. And there, in the ocean, our water molecule will rest, It may stay for a day, or a year, or 1,000 years. But one day the conditions will be right. The sun will be shining. Its warm, gentle light will stream down and find our specific molecule, floating on the surface of a wave. And it will give it that gift of energy, that invitation to fly, and the water molecule will break free, ascending, rising, leaving the liquid world behind to once more join the great invisible ocean of the sky, ready to begin the great ascent, ready to be part of the breath of condensation, ready to be woven into a cloud once more. The cycle is complete, and it is happening, always, right now, as you are lying here, resting. This great, silent, beautiful engine is at work. Clouds are being born over the warm oceans. Rain is falling over distant mountains. Fog is settling in quiet valleys. Clouds are dissipating into the invisible air all around you. The world is breathing, and you are a part of it. The water within every cell of your body has been on this journey. It has been a cloud. It has been a snowflake. It has been part of a mighty river and a vast ocean. And with every gentle breath you exhale, you release your own tiny cloud of moisture back into the atmosphere, your own small contribution to the great cycle. There is no separation. So, as you settle deeper into your rest, feel this connection. Feel the gentle, rhythmic, and dependable nature of this process. It is a source of immense peace. It is a reminder that the world is a self-regulating, harmonious system. The water that gives life is never lost, only transformed. It journeys, it rests, and it is renewed, over and over again. Let the thought of this constant, gentle cycle be a comfort to you now. Let it be the soft background music to your slumber. There's nothing for you to do but to trust in these great, slow rhythms. Let your own breath become part of this cycle. A gentle inhale, a soft exhale. Feel your body grow heavy, your mind grow quiet. You have traveled far tonight through the vast and beautiful world of the clouds. And now, the journey is over. It is time to rest, to let go, to dissipate into your own peaceful dreams. Secure in the knowledge that the great, gentle cycle of the world continues, turning quietly, beautifully, all through the night. Sleep now. Rest.